Alright, so you just got a chance to look at two videos, the one you've seen before on refraction, and the other one is a new one there where you got a chance to see a beaker kind of disappear. And so I wanted to talk a little bit about refraction. We'll kind of tie this all back in here in a bit. So like in the first case, or in any case when we're looking at refraction, we're looking at a change in the medium. So again, I'm going to sketch a quick little picture here. So this line is going to represent the two different mediums. So on this side we've got some air, and on this side we've got glass. Okay? And so when we start to look at what happens, we're looking at how a ray of light is going to go into a change in between two mediums. Now, if that ray of light, and hold on, let's grab a different color here quick. Okay. If that ray of light is going to go straight into from one surface to another, so we actually look at it and we say that it's perpendicular to each other. So in other words, this is the direction that that ray of light is going. We would see the ray go straight down, straight through. So that's what's the case when we have no angle attached to it. So there's no refraction when the angle is straight perpendicular. Where it gets interesting is when we actually take this ray and we pass it at an angle. And this is what we saw at the first one with the laser light. So you could see that the laser light was trying to go straight in one direction, but because it hits this, okay, and I'm going to drop in a little normal line for myself so I can look at these two angles. When I look at what happens here, this angle is going to change. So we actually see the refraction of this bend. Okay, so the light is actually bending as it goes from one medium to another. Now again, these angles are the important part. So like this is what we call the angle of incidence. And this one right here, this is the angle of refraction. Now, I use this symbol here. That's the theta. That's an angle with an I and an angle with an R. And when we look at this, when we go from air into water, we see that the angle of incidence is going to be bigger than the angle of refraction. So it's a situation where the angle got smaller so that we actually bend. Now, if we were to look at, say, coming back out of that glass, so here, let's put another edge to our glass here. Okay, so let's say we're going to go back into the air again. We would have that refraction occur again. So we're going to go ahead and put our line in here, and we're going to see how that refraction happens. So that's going to bring us back in line with the way that we're going. And you would see that these two rays, this one right here and this one right here, are going to be parallel, but you see that it's refracted in between. And so that shows that there's going to be edges in our glass. And so again, here's our angle of incidence. Okay, here's our angle of refraction. And this is now from, oops, this was not water, this is glass. Okay, we're going to go from glass into air. Okay, in this case, now our angle of refraction is now bigger than our angle of incidence. So it's about the optical properties of those materials. Now we call this like the index of refraction. And that index of refraction tells us about the materials. So this is a issue about the medium. So if the medium is more optically dense, okay, like glasses, the angle will get smaller. When the medium is less optically dense, it'll get bigger. And so it's as the ray travels through. Now again, this is kind of an important feature because this is like if you were looking at Say if you're looking at a piece of glass and walking straight into it, you might not notice that the glass is there. So sometimes like a sliding door might be closed and it's just really clean, but you see somebody walk right into it. Everybody else was looking at an angle and saw the refraction of that edges, where the person walking straight on didn't see it. And so that's kind of one of those things that we look at. Anyways, that's the refraction thing and how it kind of ties into looking at the oil going into the beaker. And so we were able to see it, but then the index of refraction of the oil was very similar to the glass. And so that's why it looks like the beaker disappeared. All right, now it's off to the lab. All right, so we're ready to do the lab now. This lab is going to be very similar to the one that we did with the mirrors. So you're going to see some video clips and you're going to collect your data from it. One thing to note, and this is going to be kind of the difference here, is that when we set up our meter stick, okay, we're only using 1 meter stick now, we're going to put that lens in the middle. So in other words, here's the lens. I need to know like what that mark is, and I think for most of them I put it at the 50 centimeter mark, which means that when we put the candle out here, so here's our candle, okay, our candle's right there, we need to know the distance from here to there. That's the distance of the object, and you need to measure from there to there. So don't use the marks on the meter stick as the actual number values. Use the distances from there to there. So you're going to have to like count and measure and maybe do a little bit of math to get those right. The same thing's going to be true when you put the screen out here. So the screen of where our image is going to show up, that's going to be out here. This is the distance of our image. So we've got distance of our image, distance of our object. For the first part, again, we're using that parking lot or a tree that's a long ways away. So this is our very large distance. And you're going to want to, again, get that length. And we expect this value to be kind of the same as what we calculate down here. So we're looking for those values to be the same because we want to see if we can get the focal length in 2 different ways. So with the great distance and with the small distance. So you'll watch this clip first. That'll help you get to this. And then you'll do your second clips or your trials. And so there'll be one for this one for this one, and one for this one. And again, you're just collecting these in centimeters. When you're done with that, all you have to do is do the same math that we did with the previous one. So again, it's that 1 over F equals 1 over DO plus 1 over DI. And then we'll get our magnification here. The nice thing is you'll see clearer images because the lenses give us better images. And then to finish our lab, okay, I want you to do a little discussion on how does the magnification of the image fit with the object. So write a sentence or 2 talking about that in your discussion, and then you'll be able to post this as a picture, or if you're in class, you can go ahead and just give it to me in class, and I'll mark it off there in Google Classroom. All right, so off to get your 1, 2, 3, 4 different video clips. And good luck, and then this will wrap up this activity.